I'd like to look at an old-time favorite from Year 10 called quadratic equations. Now, sadly, quadratic equations you don't perform these very well. So I'd just like to highlight the fact that e to the negative x, let's replace that with just a constant. So we've got, this is k squared, okay, e to the negative 2x is k squared, and e to the negative is simply k. So if we factorized k, you could see, okay, then k would equal 0, or k has to equal 2. Therefore, e to the negative x equals 0, that's not possible, right? Or e to the negative x equals 2. So therefore 2, the natural log, or log to base e of 2, is equal to negative x. Therefore, x equals negative log to base e of 2. Okay, so this is an e, by the way, that's an e. Fair enough when it's a simple quadratic like this, and that was a question that you had on a previous practice test. But I want to look at, let me try and paste another image here. Okay. Let me just, if I can, all right, I'll just leave it there. Now, and I'll work over here. Now this equation says 3e to the t equals 5 plus 8e to the negative t, that's a negative t. 8 over e to the t. Now, when I've got a denominator, if I multiply the left-hand side by e to the t, and I multiply the right-hand side by e to the t, both sides, then I will get 3e to the t times e to the t, 5e to the t, and this would cancel. That e to the t would cancel on that. Now, you can start seeing a quadratic unfold here. 3 to the e to the 2t, I'm going to bring everything over to one side, e to the t, minus 8. And a lot of people don't let the quadratic equal to 0 for some reason. There is a quadratic because this is double this. Now, if I let k be e to the t for this one, let's let k, a constant, equals e to the t, then this is really 3k squared minus 5k minus 8 equals 0. Now, will this factorize? B squared 25 minus 4 times 8, you get 121. Yeah, it will factorize. So if I factorize this, or use the quadratic formula, let's just use the quadratic formula. Negative b plus and minus the square root of b squared, 5 squared, minus 4 times a times c, all over 2a. 2 times 3 is 6. Now 25, take away, add 96 is 121. So we've got k equals 5 plus and minus square root of 121, 11 over 6. Let's put e to the t back. Therefore, e to the t would equal 16 over 6, or negative 6 over 6, and it can't be negative, all right? So we can't let that equal to negative. Therefore, t will equal the log to base e of 8 over 3. Let's just halve that. And you could just stop right there. And there is the solution. I give you this for a reason. I want you to see the quadratics. And once you spot the fact that we've got a quadratic equation, either factorize or use the quadratic formula. But both times you need to let the quadratic equal 0. If you let the quadratic equal 0, and then solve it using either the quadratic formula or factorizing, it doesn't matter which way you do it, then later replace the k with e to the t, or e, in this case, e to the negative x. All right, I hope that you can find questions similar to this. Look for quadratic equations. You will see quadratic equations when you have a cubic and you've got to find stationary points, because if you have a cubic and they want the stationary points. When you derive a cubic, you will get a quadratic equation. Then you have to solve that quadratic equation to let it equal to 0 where it's turning, and then you find your two x values to get. If you need a quadratic coordinate, then substitute your x in to get your y values. All right, good luck. I hope this has helped. Look for the quadratics.